Okay, today's lesson, we're going to describe and illustrate the result of two translations. What? We're going to describe and illustrate the result of reflecting a figure over two parallel lines. What? So that means we're going to reflect it twice. And then describe and illustrate the result of reflecting a figure over two intersecting lines. What? So reflect it twice. If those lines intersect, something special happens. And then describe a glide reflection. What do you think a glide reflection is? It glides, then it does what? And then what? How about reflect? Does it glide, then reflect? You want to see a special transformation? Get ready. Here's a line. Here's an object. I'm going to make an infinite cloner. No, I'm just going to clone it. Okay, ready? It glides. Yeah? Then it reflects. Oh, that's a glide reflection. Yeah? Hans, what do you think of glide reflections? They're great! You ever see any glide reflections up there in Norway? Yeah! Would that be on the lake in Oslo? Yeah! Do you ever say no, Hans? Yeah! Hans? Okay, let's get going. Yeah, the people on the web, they're just learning. All right, composition of transformations. Composition means we're going to take two transformations and combine them. Here's my first transformation. What do these things do to our object? Shift it which direction? Right 3, down 2. So if I went right 3 and down 2, and then in my second transformation, I went over 1 which way? Left 1. Okay, so just take our first transformation. I went right 3, and then I went left 1 in the second transformation. What would our composition be? What would this be? 2. So our transformation in the x direction would be x plus 2. How did I get a plus 2? I added these together. Right? And in the second piece, I went down 2, and then I went down 1. So what would happen to my y coordinate? Down 3. Easy. Just take the items, combine them using addition. All right, I got my first transformation, second transformation, combine them. So I'm going to take the xy coordinates here. I'm going to shift them to the right 2 and down 3. Check this out. I'm going to take this point. Whoa, Hans. Is this Legolas taking out your bow and arrow? Right 2, 1, 2, down 3, 1, 2, 3. Okay? If this was point A, that would be A prime, right? That's our image. Oh. Okay, I'm going to take point B. I'm going to go right 2, 1, 2, and down 3. 1, 2, 3. Boom, there's B prime. And then C prime, right 2. 1, 2, down 3. There's C prime. Here is our image. So instead of doing two separate translations, I'm just going to do one by combining them. All right. We already did this, didn't we? Did we do a reflection by hand? Yeah, what do we use? We did it with a hexagon, right? What do I do with this? I want to make that perpendicular to this and then do what? Repeat it. right? So that this is the perpendicular bisector of the segment connecting those 2 points. Same thing here. I'm probably not going to do a great job of this. I'm freehanding it. Oh, that was okay. And then I duplicate that. So then these two are the same. And I do it one more time. Let's see how poorly I can do this. Because it's going to be bad. GEO. Maybe not too bad. GEO. Yeah. Hans? What? Why would you just say your name out loud like that, Hans? Now he's quiet. That's not my best. That's actually pretty poor. I tried, though. Do I get a medal? No. I get 10 free burpees. So the distance from each point to the line on my pre-image, okay, that's these distances right here. Those distances should be the same as from that line of intersection to my image points, right? So those should all be the same, and a perpendicular angle should be formed. That's how you sketch yourself a reflection. All right, we're about to do a double reflection. Are you ready? Double. So when you're at Lifetime and you say, I'd like a protein shake, sunrise protein shake, make sure they double the protein. This was just a single scoop. Let's do a double scoop. Double scoop. Let's go. Oh my gosh, I got to reflect this twice. Let's reflect it over line 1, then line 2. Ooh. Okay, so here we go. Yeah, that's pretty good. What do you think is going to happen here? The first is going to be what? The same as the last? What do you mean by the same? Because I don't think it's going to change shape regardless. Same position, same orientation, is that what you mean? Okay, so then I reflect that again. Now I'm going to reflect this image. Move this. Now I'm going to reflect this image over this line. Okay, let's change colors. Let's go purple. For all you Kirk Cousins fans out there. That just blew $84 million on one single individual. That's cool. Let's go yellow. For all you Vikings fans out there. Oh, gosh. Maybe not the best choice. Okay, and then let's sketch this. Let's sketch our final. Oh, look, Nick's right. To get from, let's call this A, then we went to A prime, then we went to A double prime. Wouldn't A to A prime, or A double prime, this right here, wouldn't that just be a translation? Yeah? With me? Okay, just be a translation. Oh, wow, that's going to move. Can I undo that? Ungroup? Okay, let's see this. Ungroup that. I'm recording all this. That's cool. All right, shift. Pretty good. Not perfect, but pretty good. Okay, so let me just talk through something here. Let's say this orange length here is 5. I'm just making this up, okay? What would the orange length in here be? 5. Okay? What would, let's say, the green length? Do you think the green length is bigger or smaller than 5? Let's not say it's the same. Seems boring. Bigger. Okay, let's go 6. So what would that make this one? 6. Okay, so what would the distance from A to A double prime be? What would this distance here be? 22, right? Okay, now what is the distance between the parallel lines? 11. Wait, is it always double? Yes. So if you reflect an image over 2 parallel lines, so one then the other, regardless of order, the distance between the 2 lines is half of the distance of that final translation. So the translation from A over here to A double prime is 22 if the distance between the parallel lines is 11. That always holds true, always. That's kind of fun. Okay, so here you go. A composition of two reflections over parallel lines is equivalent to a single what? We said reflect. Reflect means take the first one and do what to it to get the third one? Translation. It's a shift or a translation. In addition, the distance from any point to its second image under the two reflections is double the distance between the parallel lines. Good. Okay, let's move on and look at this. All right, let's do a quick example. We kind of looked at how it works, but what would the distance be here from A to A double prime? 20. 20, right? Well, I don't know. You know, is this 6 and this is 4? Well, if that's true, this is 6 and this is 4. I see 10 here. I see 10 here. Therefore, 20, right? Just by symmetry alone. Okay, so like we said earlier, total distance is going to be double the distance between the two parallel lines. Cool. All right, but what if I do this? What if I reflect this thing over intersecting lines? Oh, this is going to be kind of funky. I think I'm going to change this image. I'm going to delete this. Delete. Where are you? Delete. Let's do something maybe a little more fun. Let's go. This is the sad kid who realized there's only 12 days left of school. What is it? Yeah, 12. Sad kid. Yeah? Sad. Okay, so we reflect. I think we can agree that sad kid would reflect up here. Yeah? And then where would sad kid reflect? So over line 1 first, then line 2. Well, I know I can't really screw up the shape of said kid's head, but how would we orient the face then? Flipped. So this? No. Go away, kid's face. Come on, kid's face. Go away. There it is. How about this? Yeah? Still no? I think that's pretty good, right? If I reflect over line 2, that'd be good. So what does this look like, right? This was, I could mark any part of that. That's our pre-image. Then we get this image. Then we get this second image. How do you think I get from A to A double prime? It's not a reflection. It's a rotation. Yeah. So it's a rotation about the point of intersection. If I took that and I rotated it from there to there, a double reflection over intersecting lines is the same as a rotation. But what would the angle of rotation be? Well, in this case, it's the same. It's a double rule. Whatever this angle is, this angle will be double that. Okay, so you can just think of the double rule. If the lines are parallel, double the length between the two lines. It's a translation. If the lines intersect, then double the angle between those two lines, and that will be your angle of rotation. So let's do a quick example with that. Oh, that's pleasant. I actually sketched it out. Lovely. Okay. So our center of rotation, like we said, let's just mark these out. What is our center of rotation? It's the point of intersection of the two lines. How far do we rotate the triangle? Well, it'd be double whatever this is. So this would be double the angle between those two lines. How does the angle of rotation relate to the angle between the two? Like we said, we double it. Okay? So a composition of two reflections over a pair of intersecting lines is equivalent to a single rotation. Yeah? Did your voice just get deeper, Hans? No. Okay. The angle of rotation is blank the acute angle between the pair of intersecting lines. Double. Oh, so we used the same word there as we did in the last one. Let's look at an example. I think I got a homework problem here. Oh, this is our glide reflection. We already talked about this one with the heart, but glide followed by a reflection. Would that be the same as a reflection followed by a glide? Would it? What do you think? Yes or no? Yes, it would be. So here is, I'm not going to do the blue eye. Oh, this kid is sad because he knows. It's Hans. Oh, Hans. What is he reaching for, you think? His ukulele? Oh, look at that. It's going to be the same. Reflection glide is the same as a glide reflection. I want to get an example. Where's my example? Dang it, I want that angle of rotation example. Name the single rotation. Oh. Okay, let's look at problem number 3. This is on your homework. Name the single rotation that can replace the composition of these 3 rotations about the same center. So here we go. Let's take a point of center of rotation. Let's take this point A. Let's rotate it clockwise 45. Then what? Counterclockwise 50. Then what? Clockwise 85. So here's A double prime. Here's A prime. So to get from A to A double prime, how much did we actually rotate? So we went 45 degrees, and then we took away how much? Took away 50. So if I go 45, then I take away 50, what do I have left? I have negative 5 degrees. But then I added 85 to that. So what am I left with? 80 degrees clockwise. Clockwise. Just adding those up, composition.